Alan Gray here with the Microbiome First Summit, underwritten by the World Asthma Foundation. We're pleased to introduce our next speaker, Dr. Patricia McIverney. Dr. McIverney is a clinical and translational researcher, research fellow at the University of Western Australia, and honorary research associate for Telethon Kids Institute. Dr. McIverney's research found that breast milk is a source of infant exposure to HTM allergen, and DERPI-1 in breast milk can act as an adjuvant and increase the risk of food and respiratory allergy. Today, Dr. McIverney presents her session, House Dust Mite Shedding in Human Milk, a neglected cause of allergy susceptibility. Dr. McIverney, over to you.
So hi everyone, I would like to start thanking the Microbiome First Summit for the invitation. It's a pleasure to be here today, and thank you for the audience. I really hope we enjoy the time we spend together today, and thank you Alan also for all this organization. So today I'm going to share with you some of the data and important questions that have been guiding my research in the last years on how we can improve allergy prevention through breastfeeding. So I would like to start talking about the origins of health and disease. So it's known that early life is a period where, let me put the pointer, where this infant is deficient in both main arms of the immune system, so the effector immune response and regulatory immune response. So it's more susceptible to infectious disease, and it's also more susceptible to disease like allergies. So it's quite clear in Western countries, for example, here in Australia, where the incidence of allergy is really high. For example, here, 10% of 1-year-old infants have allergy. So with time, this developing infant will gain the ability to mount and then to respond to a specific target, and this ability is really the key for a lifelong protection against infections and non-infectious disease. So the diet and environmental factors here early life are really key players to guide this development of the immune system. In this regard, breast milk, it's really important. First, because it's the physiological food for this baby, and it's also part of the baby's environment. So why? So we know that breast milk composition is directly related to maternal health, maternal diet, and also maternal environment. So through breast milk, the mom will transfer to the baby accumulated knowledge about the environment she was exposed during all her life. And it's important not only to passive immune protection to the baby, as we all know, because the presence of specific antibodies, but it's also important to shape and to actively shape this baby immune system. So saying that looks quite obvious, but sometimes we forget that we are mammals, so we consider the infant deficient, immune deficient, but physiologically it shouldn't be considered deficient, because it should be always be complemented with those maternal immune factors through breast milk. Okay, so the proof that breast milk is really complementing the baby immune system is the knowledge that we know that if we scaling up breastfeeding to a nearly universal levels, we can prevent about 1 million annual deaths in children younger than 5 years. So it's really the proof that breastfeeding is the most powerful way to prevent infectious disease. And we know that it's really good to prevent, for example, otitis media, diarrhea, respiratory infections. And it's also really good for non-infectious disease. For example, it has been proven that it can improve the infant cognitive performance. However, when we look to allergy prevention, the data is not that clear. So although some individual studies have shown that breastfeeding can protect from allergy, if we look to the new guidelines, meta-analysis, and systematic reviews, they all conclude that are very limited data about that, and we can't conclude that breastfeeding itself is protecting against allergy if we look to the population level. So that's the question that I want to understand and to answer is how we can then improve allergy prevention by breastfeeding. So we know that breast milk has a huge potential to prevent allergy because we know that it has a broad range of bioactive compounds that will affect parameters that are important to allergy prevention, so mainly to induce oral tolerance. So we know there is the milk microbiota, mucolytic saccharides, antimicrobial molecules that are really important to seed and then to shape the gut microbiota in the baby. Factors like epithelial growth factors that are really important for health, gut barrier. So that's important for tolerance. And also immunological factors like cytokines and immunoglobulins that will has like more anti-inflammatory properties and are important to shape the immune differentiation in the baby. So there is a lot of research on how the microbiota can help on allergy prevention, and this Dr. Lieke van der Helsen will give a very nice talk about this here. But there is not much data about how the allergens in breast milk can then influence the allergic risk in the breastfed infant. So we have been doing some research on that, and this is what I'm going to show you now. So after a long period where the allergy avoidance was the recommendation to prevent allergy, now the new guidelines, we recommend an early oral introduction to allergens. And this is around 4 to 6 months of age, and then to induce oral tolerance and then prevent allergic sensitization. And this new guideline is based mainly in the research and the data by Gideon Leck and his group showing that actually the infant will be sensitized through the skin. And if you have a delay in the introduction of this food antigen through oral route, then you don't induce oral tolerance, and then the risk to allergy is higher. So this is well demonstrated for peanut allergen, although the protocol to introduce this early in life is quite hard to in real life to follow. But there is evidence for peanut, but it's limited for other allergens, some evidence for egg, but no for fish, cow milk, and meat, for example. That's very common for allergies. Another problem is that some infants, 30% of infants, they have already allergic sensitization at 3 months of age. So the first time they are introduced to the allergen, in this case egg, they had already an anaphylactic shock and they were sensitized. So it means that we need to induce this oral tolerance really early in life before the introduction of food, and then we think that human milk can help on that. So we want to know if it's important, if it's possible to induce oral tolerance if the allergen is transferred through breast milk in the presence of all those regulatory factors that I've shown you before. So it has been demonstrated that, if you have egg allergen given to the baby through breast milk, you can induce oral tolerance and then protect this baby here in adult life, in the case, from allergic asthma. Importantly, the presence of egg itself is not sufficient to induce this oral tolerance. You need the egg together with other factors that we have in breast milk, for example, TGF-beta, vitamin A, ova-immune complex, to induce tolerance and protection from allergic asthma. So this study was published in 2008, Nature Medicine, Valérie de Hasselt, and more recently she translated this data to a human cohort, and indeed she proved that babies that were breastfed by moms with egg in breast milk, they were at lower risk for IgE-mediated egg allergy. So egg in breast milk can really protect from allergy. So knowing that we can induce now, if you have egg in breast milk, induce oral tolerance and allergy protection, we wanted to know if it was true also for respiratory allergen. So we chose house dust mite because this allergen is really common. We can find it almost everywhere and all around the world, and it is responsible for 50% of the case of respiratory allergies. So it's a very common respiratory allergen. So first we wanted to know if we could find house dust mite allergen in breast milk, because so far any airborne allergen has been detected in human milk. We know the presence of food allergens, but not respiratory allergens. So the answer is yes, we can find house dust mite in breast milk. So we have now been analyzing for a long time these allergens in breast milk, and we had analyzed different cohorts. So I combined everything here, and you can find all the details in this review here. So we have analyzed samples from Brazil, France, Australia, and the Netherlands, so almost all continents. And it's amazing that we find very similar concentration of house dust mite allergen in breast milk. So it's around 100 picograms per ml. And the percentage of positive samples are really similar among different countries. So around 60% of the moms will secrete house dust mite in breast milk. So if we compare this concentration to induction of like protein in breast milk, that usually is in the range of milligrams per ml, we may find that this is really low and maybe not important, not picograms per ml of house dust mite allergen. But then if you look the level of egg, that's a very common food allergen in breast milk, we can see it's present exactly in the same range. So yes, house dust mite is present in breast milk and it's in the same range as a food allergen. So then we use an animal model to see if we could protect the baby with house dust mite in breast milk. And we use an animal model that really mimics the human situation. So we give house dust mite to the lactating mother intranasally during the lactation period, 3 weeks, and we don't use any HFAT. However, opposite of what we were expecting, when the neonate receive house dust mite through breast milk, it's not protecting, but instead it's priming for allergic sensitization. So you can see here there is like a 5-fold increase in the levels of DERP-specific IgE and DERP-specific IgG1. So you induce allergic sensitization. Then we investigate in a human cohort. So we had access to Eden French birth cohort where we analyzed 255 samples. So we had the breast milk samples and the breastfed infant follow up until the age of 5. So we quantified DERP in this breast milk, and then we compared the babies that received house dust mite breast milk and with the babies that received with no house dust mite in breast milk. And what we saw is that having that house's mite in breast milk were related to a high risk for IgE in the infant here in the total population, a borderline to specific IgA, and higher risk for asthma or allergic rhinitis here in the group of allergic mothers. So opposite for ovo, we see that if we can find house's mite in breast milk in half of the population, and the presence of DERP1, that's the allergen in breast milk, should increase the risk for allergic sensitization and respiratory allergy. So the question now is what is responsible for this pro-allergenic effect of house's mite if we compare to ovo that was inducing oral tolerance? So most of house's mite allergens has some enzymatic activity. So for example, DERP1 is a cysteine protease, and we have also trypsin, DERP3 is a serine protease. And it has been demonstrated that those protease in the bronchial epithelial cells, it can directly digest the tight junctions between the epithelial cells, and as a consequence, you have a leak barrier, or it can bind directly to PAR receptors, and then you have released alarmins like IL-35, 33, and TSLP. And these will activate ILC2 cells and induce the proliferation of Th2 cells. So it will induce a type 2 immune response that is related to allergy. And this is well described to the lung and also in the skin. So knowing that we have house's mite in breast milk, we wanted to know what's happening in the gut of the baby. So we use the same animal model where exposure the lactating mother to house's mites, but now it does two different house's mite. We give the house's mite with the protease activity and a house's mite where we inactivated the protease with inhibitors. And then we look to the milk to see if we could find the allergen and protease activity, and also what was happening in the gut of this breastfed neonate to the gut barrier and also immune cells. So in the milk, we could find the presence of the allergen, both if the mom received house's mite with protease or no protease. So both have the protein there, the allergen, but the protease activity was much higher in the milk of lactating mothers that receive house's mite compared to control or inactivated. So indeed, house's mite is transferred to breast milk, and it still has the protease activity there. So then we look to the gut of this neonate that receive house's mite breast milk, and what we see that exactly as was demonstrated in the lung and skin, if you have the house's mite in breast milk, increase the gut barrier, so we saw a leak barrier, increase the release of alarmins, so 10 times more IL-33. We have an activation of ILC2, so they secrete more IL-5 and IL-13, and it was also related to expansion of Th2 cells in the luminal propria. So this demonstrated that even that really tiny amount of house's mite in breast milk, it can damage and induce a type 2 inflammation in the gut of the neonate. Okay, so I show you that we have house's mite in breast milk, and due to this protease activity, it will act as an adjuvant and induce this immune premium through the gut. In the other hand, we know that now that if you have ovo in breast milk, you can induce regulatory cells and then induce oral tolerance and protect from allergy. So the question now is this adjuvant property of house's mite impacting the oral tolerance to an unrelated allergen if it's there in the gut at the same time. So can we still protect from food allergy and induce oral tolerance to OVA in the presence of DERP? So to answer this question, now we give both allergens at the same time to the mother in the animal model. And then we look again in the gut to see what was happening. So first we confirm that yes, if we give egg to the lactating mother in the breastfed pup, we can induce C regulatory cells. So here's the control. So we increase the number of over-specific Treg cells, and we also protect against food allergies. So here's diarrhea score and over-specific IgA. However, when we give both allergens at the same time, House's mite and OVA, then we abolish the capacity to OVA to induce Treg. We don't have this anymore. And also, we abolish the protection against food allergy. And if we give the House's mite with low proteins activity, we restore then the ability for Treg and allergy protection. So just to conclude here, so yeah, having house dust mite in breast milk, it's a risk factor also for food allergy here in our animal model. So as always, we wanted to translate this to the human scenario. So we looked in a human cohort, now IFOS human cohort, to see if the presence of House's mite in breast milk was now related to food allergy. So first we analyze the milk samples from this cohort for the presence of DERP1 and OVA. And as we can see here, is quite heterogeneous. So some moms will have like no allergen in breast milk. Some moms were positive. So this is this group. Some moms were like positive for DERP, but negative for OVA here. Some positive for OVA and negative for DERP, and some moms will have both allergens. So we split the moms on these groups, the infants actually that receive breast milk with or without the allergens, and then we look the prevalence of IgE-mediated egg allergy. And exactly as our mouse model, we thought that the higher prevalence of IgE-mediated egg allergy was in the group of babies that received DERP in breast milk, but no OVA. And the lowest prevalence was in the group of babies that received DERP, that received OVA, but no DERP. So showing again that DERP may be a risk factor for food allergy and OVA a protective factor for food allergy. Okay, so in conclusion, we know that now that House's mite in breast milk is not good. It can increase the risk for allergic sensitization and respiratory food allergy. So it looks like if we want to improve allergy prevention through breast milk, we need to find a way to avoid the presence of House's mite in the milk. So the question is, can we prevent House's mite shedding in human milk by environmental control? So we looked at that. So we just published last year, in 2020, this paper. And we looked at in PIAMA for the cohort, 254 samples, sorry. And we looked at the presence of DERP1 in breast milk and in the dust. And then we choose maternal mattress to look to that. So here we have 36% of the samples in breast milk were positive to DERP1 and 64% the samples of maternal mattress was positive to DERP1. And the question was, is this related to the presence in breast milk? So we found absolutely no correlation between house dust mite in the dust and the levels or the presence of house's mite in breast milk. So here in this first graph, you can see the concentration of DERP1 in breast milk, and we split the moms that were negative to DERP in the dust and the moms that were positive in the dust. And you see that the concentration is really similar between both groups. And here we have just the percentage of positive samples in breast milk. Again, if the moms were negative or positive to the DERP in the dust, in the mattress, and the percentage of positive samples are the same. And here is the correlation between DERP1 in breast milk and DERP1 in maternal mattress, and there is no correlation. So actually, we weren't like surprised with this data because in our previous work, we analyzed some proxy of allergen exposure. We didn't have the measurement of DERP1 in the dust, but we knew some, like if the moms have a carpet at home or the habit of cleaning or the number of inhabitants in homes, some proxy of allergen exposure. And we also didn't find any correlation with the levels of DERP1 in breast milk. We also had some data from the Brazilian cohort on the levels in breast milk and dust. That's not published, and there is no correlation. And we know that there is also a poor correlation between the presence of food allergens in breast milk and the maternal food allergen consumption, even in the clinical trials where we know that the amount of food allergen is really well controlled. So here in the table, you see some examples of like egg allergen in breast milk. So for example, in this randomized clinical trial where the mom received, for example, one cooked egg, only 68% will secrete in breast milk. Or here, in high egg diet, 58% only will secrete egg in the milk. So half of the lactating mothers will not secrete allergen in breast milk, even after control amount ingested. And what is more surprising is that the moms that were under the strict diet with no egg consumption always also secrete some allergen in breast milk. So, for example, this is no egg, 30% had allergen in breast milk. Egg-free diet, 37% had allergen in breast milk. And this can be explained by some exposure to egg in the environment, for example, exactly like house dust mite. And so finally, we use again the PIAMA birth cohort. What we wanted to know is if house dust mite were really an independent source of allergen exposure. House dust mite in breast milk was an independent source of allergen exposure. So in the same cohort, we had access to breast milk and the dust, and then we measured DERP1 in the breast milk and the dust, and we see the clinical follow-up until the age of 16. So then we compared the levels of total IgA and the prevalence of asthma in the infants that were exposed to DERP1 through breast milk or to dust. And what we see is that exposure to breast milk was related to increased risk for high levels of total IgE and a trend for higher prevalence to asthma that wasn't observed here when it was exposure through the dust. So DERP1 is in human milk, but not dust, is associated with this increased level of total IgA. And this is in accordance with our previous data, again, for the French cohort, and also previous data in the PIAMA birth cohort showing that exposure through the dust doesn't increase the risk for asthma or allergic sensitization. So, in conclusion, now we know that early life breast milk is also to be considered a source of infant exposure to House's mite. DERT1 in breast milk can act as an adjuvant and increase the risk for allergic sensitization, respiratory, and food allergy. And the levels of DERT1 in the dust is not correlated to the levels in human milk. So we can consider breast milk as an independent source of House's mite exposure early in life. And I think the key message actually is that now in this era that we exposure the kids very early in life to induce oral tolerance to allergens, we need to know that oral route can also be a route for allergic sensitization, even in the presence of all these breast milk modulatory factors, and this will depend on the allergen that you are exposing the kid. So knowing now that House's mite in breast milk is not good to prevent allergy, and we can't really control the presence of House's mite in breast milk, how we can promote allergy prevention through breastfeeding? What's next? So we really think the good strategy is doing some maternal intervention to modify the breast milk composition and try to promote a more immunomodulatory breast milk profile. So doing that, we believe that then we can create in the gut of the baby a more tolerogenic condition. So when the infant will be in contact with the food allergen, we can induce oral tolerance. And another way is start to modulate the allergen shedding in normal milk, increasing or decreasing depending on the allergen. By other means, then controlling exposure. And for that, we think that the diet and maternal microbiota is really important and good targets because we can modify. And we believe that by changing the diet and microbiota, the way that the mom will digest the antigen will be different, and this will impact how this allergen will be shedding in the milk. So we started to investigate that. So we have a project on that. It's the Gateway for Allergy Prevention. So it's a project that we use samples from the SIMBA randomized clinical trial. That's from Origin cohort. And in this trial, the moms will receive prebiotic supplementation during pregnancy and breastfeeding. And then we will analyze the breast milk samples at 2, 4, and 6 months for the presence of many bioactive molecules, the microbiota for sure. But we also wanted to see the allergens, food and House's mite allergens, breast milk, and the protease activity in breast milk. So to see if this prebiotic supplementation can shape this breast milk composition for a more tolerogenic composition. And then, of course, we'll see if this can then decrease allergic risk in the infant. So I don't have data on that now, so it's data I hope soon we'll have some very nice data to show you about this project. So that's all for today. I would like to thank you. First, my team. This is the team of Valérie Verhasselt, head of the Center of Breastfeeding and Immunology. This is myself. This is Akila, a postdoc in the team that she's responsible for most of the mouse models that I show you. This is Lick, that she's going to give a talk about the breast milk microbiota. This is Nivi, she's working that work that I told you about SIMBA cohort. And this is Savannah, a student in our team as well. So I would like to thank, of course, all our collaborators, especially the ones involved in all those birth cohort and our sponsors. And you for the audience, so I hope you have learned something new today. Thank you.